Alright, so we're going to do 5.58, and then tomorrow we'll finish all this stuff. So we have double angle formulas we're going to talk about first. And I'm not going to take the time to write down the formulas since you have the formula sheet in front of you. We'll kind of write them as we go. So example 1, we're going to find the exact values of sine of 2 theta, cosine 2 theta, and tangent of 2 theta. If the cosine of theta is equal to 5 over 13, and theta is between 3 pi over 2 and 2 pi. Okay, so first of all, look on your formula sheet. Do you recognize that this is a double angle formula because of this 2 theta everywhere? Okay, you see that? Okay, so now I'm hoping that at this point in our pre-calc career, we notice that this information is going to require you to draw a triangle. Okay, and that we can see that it's going to have to go in quadrant 4. Everybody agree with that? Okay, so let's start there. So we're going to draw this triangle. It's in quadrant 4. Cosine is 5 over 13. Okay. So what does that make our missing side? I'm sorry, what? Negative 12. Right? Because all y values are negative in quadrant 4. Okay, so now, in order to use these formulas, you have to know sine, cosine, and tangent. So I'm just going to go ahead and gather that data. So sine of theta is negative 12 over 13. Cosine of theta is 5 over 13. And the tangent of theta is negative 12 over 5. Based on my triangle that I just drew. Okay, so the first thing they want us to evaluate is the sine of 2 theta. So everybody take a look at your formula sheet. The formula for this is 2 times the sine of theta times the cosine of theta. So this is the formula I'm going to use in order to evaluate. So now, just like before in 5.4, all you have to do is substitute in your values. So I'm going to have 2 times negative 12 over 13 times 5 over 13. And then I'm going to multiply, so this gives me negative 60 times 2 is negative 120 over 169. I've had a few years of math experience. And this is sine of 2 theta. Okay, and that's it. That's all this one is. You try to simplify it if you can. It doesn't simplify, so we're good. Everybody okay with that? All right, now let's try to do cosine. So cosine of 2 theta, let's take a look at the formula sheet. Okay, that is the cosine squared of theta minus the sine squared of theta. And now I'm just going to plug in my information. So the cosine squared is 5 over 13 squared. And sine is negative 12 over 13 squared. Okay. So go ahead and square those pieces. So 25 over 169. Let's see, minus a positive 144 over 169. This gives us negative 119 over 169 when we subtract. And it doesn't simplify, so this is it. Cosine 2 theta is equal to negative 119 over 169. Pretty easy, right? Plug it in, multiply, simplify, you're done. Alright, let's find tangent now. So tangent of 2 theta. The formula is 2 tangent of theta over 1 minus tangent squared. Notice that tangent's going to get messier than the others. Okay, so I'm going to plug it in. I have 2 times negative 12 over 5 over 1 minus negative 12 over 5 squared. Alright, so multiplying in the numerator, I get a negative 24 over 5. In the denominator, I'm going to have 1 minus 144 over 25. Okay, so this is the same stuff we've been doing for, I feel like, months now. Gonna get that common denominator, right? Multiply by the reciprocal is what you guys like to do, so that's what we're going to do. We're going to get that common denominator, which is going to be 25. So that 1's going to become 25 over 25. Everybody agree with that? When I subtract those, I get, let's see, negative 24 over 5 in the numerator, and then that negative 119 over 25 in the denominator. So we're going to multiply by the reciprocal. Right? This is going to give us a positive, let's see, the 5s are going to cancel, leaving us with 5, so positive 120 over 119. And that's tangent of 2 theta. Everybody comfortable with that? The process, plugging it in, simplifying. Any questions? So that's like the double angle formula. That's all there really is to it in terms of substituting in. Sometimes you're going to have to solve one of these types of problems. So we're going to try that next. Sure. Okay, example 2. We're going to solve for x. We're still going to have that same restriction of 0 to 2 pi. Now keep in mind, because yesterday I saw some of this, if you have a choice between 0 and 2 pi, which are the same location, right, different representation, you have to choose 0. You cannot choose 2 pi. It's not included in the restriction. Okay, so you have to write 0. Alright, so if we have 2 cosine of x plus sine of 2x equals 0, and I want to solve. Taking a look at this, the sine of 2x. We solved equations that had sine of 2x in them before, right? Yesterday we did. But all of the terms were being multiplied. So we could go right into using the zero product property and then thinking about the fact that we had to double our solutions and all that good stuff, right? This is not like that anymore, right? Can you use a zero product property right now? No, because of this plus. Okay, so you have to figure out a way to change this. Okay, so this piece has to change. So taking a look at the formula sheet, do you agree that you could use a double angle formula to change it?
Yes.
Okay, so you have to recognize that. And that's one of the tricky parts about 5.5 is that you have to look at this equation. That the directions are just going to say solve, and you have to realize you have to substitute using that formula first. So this is the double angle formula we're going to use. Alright, so we're going to substitute that in. So this is going to give us 2 cosine x plus 2 sine x cosine x equals 0. So I just used the formula, substituted it in. You had a problem just like this yesterday, right? So now we're going back to 5.3. Now we're ready to solve this type of equation. So what do you do now? Pull out that 2 cosine x. We're left with a 1 plus sign. Right? Now we can use a zero product property. Now we're multiplying our terms and they're set equal to 0. So at this point we can take both of these, set them equal to 0, and solve. Okay, so where's cosine 0? Pi over 2 and 3 pi over 2. Where is sine negative 1? 3 pi over 2. So we have an overlap. We don't list it again. These are our only two solutions. And that pretty much covers the double angle formula. Okay, questions? Moving on? Okay, you guys seem like you're having a lot of fun. Okay. Next thing we're going to talk about is power reducing formulas. If you were having fun before, you won't be after this. Yes, it's much better. It's super believable.
Are you gonna like create a problem where you're reducing formula and then throw in a double angle in there?
It's going to be nothing but fun. So maybe.
Yeah, you are.
Pardon me?
Like, can I, like,
This is going to take up quite a bit of space, yeah. All right. So now we're going to move into the power reducing formulas. So I want everyone look at your formula sheet, check out the power reducing formulas. Okay, there are 3 of them. Take a look at what they look like. All right. Now, these directions are incredibly clear. They say reduce the power. That's a good signal that you might need to use the power reducing formula to do so. Okay?
So on the test, it's going to say that.
No.
It's not the test.
No, it's going to say something like simplify.
Sweet.
Okay?
Okay.
So
So what was like the whole...
sometimes it'll give you a specific direction. Sometimes
more than just
now more than verify, yeah. So now, in order to use this formula, don't you have to have cosine squared? Right? Everybody agree that this is going to be a cosine equation, right? So, do you also agree that cosine to the 4th is the same as cosine squared times cosine squared? Okay? So, we can change it, all right, at the beginning. And so now what we want to do is we want to take a look at the formula. So right now, I'm recognizing that I have to use my cosine squared, and I'm not going to write x, I'm actually going to write u, because that's what the formula sheet says. We're going to talk about that. So cosine squared of u is equal to 1 plus the cosine of 2u over 2. Okay, so before you start using the formula, okay, after you recognize that this is what you need to do, you need to now identify what is u. Okay, so taking a look at this, what is u based on our equation? It's x, right? And it seems pretty basic, but we're going to change our u in a little while. Okay, so just make yourself a note that we're using u is equal to x. Now I'm going to have to plug this in 2 times, right? So I'm going to use the formula here and here. So I have 1 plus the cosine of 2x over 2 for the first piece, because I'm plugging in x for u. I'm using this formula for this piece. Now I'm going to do the same thing again for this piece, and it's going to be the same thing because it's both cosine squared of x. Alright, everybody okay with substituting it in? So now we have to multiply, and in order to multiply fractions, you have to multiply, numerator times numerator, denominator times denominator. And so this is where we're going to take a little side note, because there were some major illegal things happening yesterday, and I want to address some of them. So we're going to talk through this. So in the numerator, we have to FOIL, right? And the denominator is just going to give us 4. So here I'm going to have 1 times 1, so I get 1. When I do 1 times cosine of 2x, I get cosine 2x, but I'm going to have 2 of those, right? So plus 2 cosine of 2x. And this is where I want to take a little break and talk about this. When you have cosine of 2x times cosine of 2x, maybe we should do this in pink so you know. Okay, this is not part of the problem. This is just me thinking of some nightmare problems I graded. So when I have this, cosine of 2x times cosine of 2x, what do you get?
Cosine squared.
So I heard 2 answers. I heard cosine squared of 2x, and I heard cosine squared of 4x. Which one is right? Cosine squared of 2x is the correct answer. Okay, now let's think about this. That is so illegal to write 4x. You do not multiply those together, okay? That represents the angle. You don't change it. Think about when you get cosine of x times cosine of x, you're just combining these terms. You get x squared, okay? This is not cosine squared of 4x. That is really, really illegal. The other thing that is super illegal is if you had something like this. Let's say, for example, you had 2 sine of 2x times the square root of 2 over 2. Does that look familiar to you? Yeah, it should.
Bro, I got it though.
Now, you cannot multiply this 2 and this 2 together. That is illegal. You are allowed to multiply this and this together, canceling the 2, therefore giving you the sine of 2x times root 2, not the sine of, let's see, you got 2 sine of x times root 2. Super illegal, super illegal. Okay, this is like locked in. You can't change that. Just like it's locked in here, you can't change that.
I like the pattern.
Yeah, there was a lot of stamping going on this problem, okay? Please don't do this again, okay? You see what I'm saying here? Major illegal move, don't do it. We only do legal things this year. Now, let's go back to power reducing. Just think about that, all right? Now, here, this is going to give us the cosine squared of 2x. Okay, now the first thing is we don't like fractions. We, as in you, don't like fractions. So if you don't like the fraction, we can get rid of it. And the book doesn't like it either. So the book's going to do this too, and I encourage you to do so. Dividing by 4 is the same as multiplying by what? A fourth. So what I'm going to do instead is I'm just going to pull this 1/4 out and write it like this. Now you might think to yourself, we're done. That was simple. But we're not. Because it said to reduce the power. And so when it says to reduce the power, what it's meaning is you have to reduce it down so that everything has a power of 1 or less. So looking at this, we have an issue with this term right here. Okay? It's not reduced yet. So that means we get to start this problem all over again. And we get, yeah, these are horrible. We get to use the formula again, okay? Now, looking at this term right here, everybody agree this is the only term we're going to have to reduce the power for? So everything else is going to stay the same. So I'm still going to have the 1/4. I'm going to have my 1 plus 2 cosine of 2x. But now I have to change this piece. And so before I made you think about what u was, and now I'm asking you to do the same thing. So what is u now?
2x.
Yes. So now we're not going to plug in x, we're going to plug in 2x. So you really have to take a look and see what your u value is. Okay? So now I'm going to have plus 1 plus the cosine of 2 times 2x all over 2. Because this time u is 2x. Okay? Now, these, I'm going to ignore the 1/4 for a second. So looking at these, they don't have a common denominator yet. I'm going to get a common denominator because it's going to be nicer, right? It's going to look a lot nicer than this because this is clearly not simplified. So to get a common denominator, everybody agree it's going to be 2. Okay, so to make this piece 2, I have to change this to a 4, right? To make this denominator 2, I'm going to have to change this piece to a 2. All right, so I'm just getting a common denominator there. Now I'm going to simplify, so I have 1/4 times 2 plus 4 cosine 2x plus 1 plus the cosine of 4x all over 2. Okay, so we're almost there because now looking through this, I can see I have reduced the powers. Okay, so this is good. I just want to simplify now. So dividing by 2 is like multiplying by half, right? So if I factored out the 1/4, can I also factor out a 1/2? So this is going to give me an 1/8 on the outside. And then I'm just going to reorder this. So cosine of 4x plus 4 cosine of 2x, bless you, plus 3. And now I have reduced the power.
What did you take?
1/2. Okay, and then I just combined that 2 and 1, giving me the 3, and I reordered everything.
So you can just keep the one, you can put something for it.
Because this 2 times my 2x here. Yep, because it's all locked in together.
Doesn't this just equal cosine times cosine times cosine times cosine? Can you just expand it and make the whole world happy?
No,
Why not?
because the whole world can never be happy.
That's a really good question.
Oh, wow. Oh.
All right, moving on.
If I disagree, doesn't believe in world peace, you heard it here.
All right, the next thing. When I times it by what? When I distribute the 1/8? It just looks nicer like that. This is how the book will leave their answers too. Okay? Yeah. All right.
Are we doing every single formula today?
Yes, I can go back.
These 3 formulas.
Now, the last formula we're going to talk about today is half angles. We're going to save the last 2 sets for tomorrow. But today we're going to do half angles as well. Can I move this now?
Yeah.
Okay. So, before we start into the next example, I want you to take a look at the formula sheet. Okay? Looking at the half angle formulas, notice that sine of u over 2 and cosine of u over 2 have a plus and minus out in front. If you take a look at this box goes with the half angle formulas, hence the direction. Okay? Now, you have to figure out which sign to choose. So do you choose the positive or do you choose the negative? So this is all going to go back to that idea of all students take calculus, and that tells us where each of the trig functions are positive or negative, right? If your angle is given in quadrant 1, okay, then when you evaluate u over 2, or 1/2 of u, or the half angle of u, however you want to think about it, your answer is going to be in quadrant 1. So in that case, everything would be positive and you would only choose the positives. If you take a look at like this case, where if u is in quadrant 3 when it's given, so when you draw the triangle and you were originally in quadrant 3, your answer, u over 2, will be in quadrant 2. Now if you were evaluating sine, you would choose the positive, because sine is positive in quadrant 2. But if you were evaluating cosine, you would have to choose the negative, because cosine is negative in quadrant 2. I can see that. We're going to look at an example, but we have to use these rules. Okay? So u is what is given. Okay? U is your original given thing. So what's going to happen is we're going to have to draw a triangle for these. In the problem. Yep. Then we're going to have to do u over 2 to actually find the answer of the half angle. And when you do that, dependent on where your answer ends up, is going to depend on whether you choose the positive or the negative sign out front. Okay? All right. So keep that out, and we're going to try this. So this is example 4. All right. Find the exact values of sine of u over 2 and cosine of u over 2. If the sine of u is 5 over 13 and is in between pi over 2 and pi. Okay, so again, before you do anything, you're going to have to draw a triangle. Okay, so we're going to draw a triangle based on the information, which quadrant is it in? 2. So I'm going to draw this in quadrant 2. Sine is opposite over hypotenuse, which makes the adjacent side negative 12, because x values are negative in quadrant 2. Okay, now, this represents u. So for my information that I need, I'm going to need sine, which is 5 over 13, and I'm going to need cosine. which is negative 12 over 13. Okay, so that's step one, is you figure out where u is, you draw the picture if needed. Okay? Now, part two, before we start actually finding out what the sign of u over 2 is, we have to decide which sign we're going to choose. So, u is given in quadrant 2. Does everyone see that? U is in quadrant 2. Okay, that's where we drew our triangle. Then, when we do u over 2, or 1/2 of u, okay, look at your little box here. If u is in quadrant 2, then 1/2 of u is in quadrant 1. So that means that our answer ends up in quadrant 1. Okay, well now based on our all students take calculus, if our answer is going to end up in quadrant 1, what sign do we have to choose whether we're evaluating sine, cosine, or tangent? Positive. So all answers are positive. Okay? Really, really important. Okay? So now let's find sine of u over 2. Alright, so looking at our formula sheet, it would be the plus or minus the square root of 1 minus cosine of u over 2. But we're going to choose the positive because we just decided on our rule. Okay? So now we're going to do 1 minus the cosine of u all over 2. Okay, so now I'm going to just start substituting in and simplifying. So the cosine is negative 12 over 13. I'm going to plug in negative 12 over 13. All divided by 2. Okay, so now I have lots of fraction work, and to top it off, it's inside a radical. Right, so I just want to remember all of my rules here. Okay, so this is going to give me the square root of, let's see, this is like 13 over 13, right? So I get 13 plus 12, so 25 over 13, all divided by 2. Basic algebra. Where are we having a problem? Oh, okay. Okay. So now, dividing by 2 is the same as multiplying by a half. So now I'm going to get the square root of 25 over 26. So now remember, that's like the same thing as the square root of 25 over the square root of 26, right? So I get 5 over root 26. Almost there. Finally, you have to rationalize, right? So we're going to multiply by the square root of 26, giving us the sine of u over 2 is equal to 5 root 26 over 26. Go back here. Maybe make yourself a note that the reason why we chose this positive sign was because of that rule. Okay?
On the quiz or answer, it's going to say like it has to give us the quadrant originally, right?
Well, you have to figure out that in this case, it was in quadrant 2.
Yeah, so then like our half would be
Right.
based on
It's going to be based on your given information.
Okay.
Yes. Okay, moving on to cosine of u over 2. Okay,
I
so
guess.
looking at the formula sheet, again, you would choose between the positive and the negative, but we've already decided that all of them are going to be positive. So I'm going to choose the positive square root of 1 plus cosine of u over 2. And this is going to be like the same thing we just did, except now we're going to be adding cosine. All right? So this is the formula we're going to use. That positive piece was chosen because of the rule here. And now let's plug in what we have. So we have the square root of 1 plus a negative 12 over 13 all over 2. Now 1 is just like 13 over 13 again. When you subtract the 12, you get 1 over 13 all over 2. And all of that is under the radical. Dividing by 2 is the same as multiplying by a half. So again, we get the square root of 1 over 26. Which, again, when you take the square root of both of those pieces, you'll end up with the square root of 26 in the denominator. Have to rationalize again. All the same type of steps that we had before. So cosine of u over 2 is equal to the square root of 26 over 26. Questions? So now, let's move on. Still talking about half angle formula though, okay? So this was pretty obvious where you had to draw the triangle, u was already given, we were good, okay? This next example we have to do a little bit more thinking. So, let's say find sine of 105 degrees using the half angle formula. Now, based on the directions, they're already telling you use the half angle formula. So, hopefully you would know to choose one of those. The fact that they gave you the sine of 105 degrees, which one do you think you would use? Sine, cosine, or tangent? The sine, because the sine was given, okay? So I know that I'm going to have to use the sine of u over 2. The next thing that you have to do this time is decide what is u. So that is my question to you. What is u?
Did you have to do...
I've heard 210, 105, and 52.5. And so my question is, which one is it? So some people think it's 52.5, some people think it's 105, and some think it's 210. Why is it 210? Right. This represents the sine of 105 degrees. The only way to get this equal to 105 degrees would be to start out with the sine of 210 over 2. Okay? So that's the first part, is you have to decide what is u actually. Okay? So you just double it. Also, think about the other choices. We thought maybe 52.5 or maybe 105. Are either one of those unit circle values? No. So that's really not going to work, right? But 210 degrees is. Okay? So think about that as well. Now, we have to decide which sign to use, because this, for sine of u over 2, you could choose the positive or you could choose the negative. So now we have to decide where we're at. So 210 degrees, which is u, is in quadrant 3. So go to your rule box. If u is in quadrant 2, then u over 2 is going to be in quadrant 2. So we started in 3, we're going to 2. I said 2 and 2. I know. So we started in 3, and we're going to go to 2. Now think about all students take calculus. Sine is positive. We're evaluating sine, so we choose the positive sign. So we're going to use the sine of u over 2 is equal to the positive square root of 1 minus cosine u over 2. We pick positive because sine is positive in quadrant 2. This represents u, and this represents u over 2. Okay, and now we just plug in what we know. But now we have to think about what we know, right? Because we don't have a triangle given this time. So now we got to think about the coordinate of 200. Oh, this is dying. Not good. So now we have to think about the coordinate at 210 degrees. What is it? Negative root 3 over 2, negative 1/2. Right? This is cosine. This is sine. and now we have to plug it in. So I have 1 minus a negative root 3 over 2, all over 2. Same stuff I did before. Get a common denominator. I'm going to end up with 2 minus root 3 over 2, all divided by 2. Oh, this was a negative, wasn't it? Yeah, thank you. 2 plus root 3. Okay, dividing by 2 is the same as multiplying by a half. So that's going to give me the square root of 2 plus root 3 over 4. And now when you take the square root of that, we're not going to have to rationalize, right? Because 4 is a perfect root. And then we get 2 plus root 3 all under the radical in the numerator, which looks really weird, and we've never seen an answer like that before. But that's just what it is. It works. So that is the sign of u over 2. Yes?
So here it asks us specifically to use the half angle formula. If it was on a test, could we use the sum of difference?
Yes. Yes, you could, if it didn't give you a specific. Absolutely. Now, what if, I'm just going to change the scenario. So this is example 6 now. What if it said find the cosine of 105 degrees? How would this look different? You have a question?
I had a question going back.
Okay, go ahead, go back.
Like, so on the test, if it just says like simplify or verify,
You can use whatever you
use
want
whatever
to
you
get
want.
there.
Okay.
Yep. Okay, so looking at example 6 now, if this said find the cosine of 105 degrees, how would this be different? Why would it be negative?
Because cosine's not negative.
Exactly. So even though you would be evaluating the cosine of 210 over 2, which u is 210 degrees, it's in quadrant 3, your answer ends up in quadrant 2. But cosine is negative in quadrant 2. So you would have to choose the negative formula of 1 plus the cosine of u over 2. See the difference? And that's the first half of 5.5.